Hello, AP Statistics. This is section 2.1, describing location in a distribution. All right, so the first thing we're going to talk about is percentile of a distribution. That, by definition, is the value with p% of the observations less than or equal to the respective value. Okay, so let me show you how we're going to use that. We'll talk about, for a second, Amazon. Okay, with each Amazon purchase, customers are encouraged to write a review and leave a rating up to 5 stars based on their satisfaction of the products. The average star rating for each item is then calculated and is accessible for interested customers to view. The following scores represent the average customer review for 25 random athletic shoes. For convenience, they are listed in ascending order. All right, so here's what's going to happen. We're going to talk about one specific shoe that is a part of this group, and that is the men's Air Jordan Retro 3, and they're asking for the percentile. Okay, now it gives you a rating of 4.2, which is right here, and I'm going to write a fraction to start this off with. Okay, based off all the athletic shoes that were assessed, there are 25. Okay, and if you start from the lowest and move your way in ascending order to our marked value, which is 4.2, you can count that there are 13 on the top row, 14, 15, 16, 17, 18 overall. Okay. And if you divide that out, 18 divided by 25, that gives you 0.72, or the 72nd percentile. Easy fractions, all right? If I look at the second one, it says, what is the percentile for the men's Nike Free 5.0 with a star rating of 4.8? Now, this is the highest rated one. Okay, so out of the 25, it is superior, okay, which is the very best. All 25 are at least that or equal to 4.8, which is the 100th percentile. Okay. Finally, it says, what is the percentile for a women's Air Pegasus 32 and a men's Air Pegasus 32 whose independent ratings were 4.6 from Amazon? Okay, those are each here. And those are actual ratings at the time for that respective shoe for each of them. And it was from different people, and they just happen to have the same rating. And out of 25, the numbers that are less than or equal to that, well, there are 23 out of those 25. Right? And that represents 0.92, or the 92nd percentile. Okay, very simple fractions. People sometimes will ask, should I leave it like this? Can I just leave it as a fraction? It's kind of okay, but it doesn't really answer the question, because usually they say what percentile, and you don't really say it's the 8/25th percentile. You usually want to put it in a context that makes sense in terms of answering the question. Okay, awesome. All right, here's what I got next. This is the age distribution of the 2017 USA women's soccer team. All right, now you can take a look here that these are the respective age groups with an interval of 3. And to the right of that is a column of numbers that represent the counts for each of those age groups. All right. The next column talks about a relative frequency. And that's the beginning of this work here. What is a relative frequency? It's sometimes forgotten about, but it's actually something that's very easy. It's a very easy idea. All you're going to do is find the percent of athletes that are in each of these age subgroups. Okay, so if you look at the first subgroup, there's only 1 athlete out of all of them. And how many is all of them? Well, if you add these all up, you do get 23. So 1 out of 23 of these athletes is between 18 and 20. Okay, that's pretty awesome for our national team. And I'm going to write the relative frequency or the percentage for that. That is 0.0435. Okay, and then I'll repeat it for the next one. There are 5 out of 23 in this group, and that is 0.2174. And then I'll do 7 out of 23, which is 0.3043. Next item is 6 out of 23. That is 0.2609. And then the last two are the same. They're both 2 out of 23. That gives me 0.087 and 0.087. All right. Now, without maybe a little bit of rounding error, the idea is that if you were to add up every single age group with respect to its relative frequency, this should give you something pretty dang close to 1. All right. If it's slightly off, okay, maybe it's a couple hundreds of or thousands of a decimal short or maybe above, it has to do with the rounding that you had when you divide these out. Okay. If you were to add up the fractions, you would get 23 over 23. And this would actually be pure. Okay, that works out perfect. Okay. All right, now cumulative. What does cumulative mean? High school students may recognize the word cumulative in terms of a GPA. A cumulative GPA is a GPA that is representative of not only what the student did the current semester, but everything in front of that as well during their high school career. Okay, so at the end of someone's junior year, there is a GPA for the current semester, and then there is a cumulative GPA. And the cumulative, again, is the representative GPA for all 3 years thus far in high school, assuming that you go to high school freshman through senior year. Okay, but I just want the regular frequency. I don't want the relative frequency. Cumulative frequency just means this. I'm just going to put a 1 here in the first spot. And when I have the 21 to 23 age group, that's 5, but I want everything before that as well. Okay, so not just 5, but I want 5 and the 1, which is 6. All right, and if I did the next group, that is 7 plus 5 plus 1, which gives you 13. And then I'll do the next item. It has a 6 in this row, but I have to add everything else before that. Students will say, do I have to show my work? And the answer is no. You can just add these up. Okay, I'm just showing you so you understand how I'm getting it. Same idea for the next row. I'm going to include the 2 plus everything above that, which is 21. And the last one, if you add up everything from top to bottom, which we have already done, you should get 23, which is the same as that guy right there. All right, so this ending should match the original total. All right, now if I did the same thing for cumulative relative frequency, what I'm going to do is I'm going to add everything up from this group. All right, so the first part will start the same, 0.0435. And then the second cell, I'm going to have, well, I'm going to have 0.2174 and add to that 0.0435. All right, and what does that give me? It gives me, I'll put it off to the side here, 0.2609. Okay, and then I'm going to take that 0.2609 and add it to the cell that was for this respective row, 24 to 26. And if you add those up, you will get 0.5652. And if I add the next row to that, it's 0.8261. Add 0.087 to this, 0.913. And the last one should be 1.00. Okay, or something pretty darn close to that. Again, you should get something within a couple hundreds or maybe a thousandths within this number here. And again, if not, it's just because you're adding these all up, okay? And they're rounded from the beginning. And sometimes rounded numbers don't always give the perfect result. Nevertheless, this number here should match that guy. All right, now what am I going to do to graph this? Well, off to the right. Here's what I'm going to do. I'm going to put 18 in this spot. And I'm going to put 21 here. And 24. 27. 30. 33. And 36. Okay. And this is going to represent ages. Ages of women's USA soccer. Okay. And this, of course, will be frequency. Okay, so again, they ask for, if I look up here, that item, that represents this relative frequency, sorry. Rothery. Okay. Represents that respective column here. Okay, so what do I want to count by? Well, notice the highest it goes to is 100%. Okay, so let's see if I have 10 boxes here, or 10 lines going up. I got 1, 2, 3, 4, 5. I think I'm going to pull this off. That's 0.5. 6, 7, 8, 9, 10. Okay, now remember, when I have 18 to 21, while this goes to 20, sorry, this goes to 18 to 20, 21 is a boundary. So any values of 21 that would exist would fall into this right-hand side here, okay? It's not gonna fall into the left-hand side. When we look at a value for an interval here, we always look at 18 and it basically goes up to 21, but not including it, okay? So this is 0.5, which means each of these are about 0.1. Okay, and I'm not going to have too many of those in the lower end. 0.0435 is almost half of that, so I'm going to fill that in. And the next one is 0.2609. So 2609 is about right here. The third item is 0.56. Okay, it goes up about that high. The next one is 0.82. Now 0.9 is right here. 0.8 is just below it. So I'll just write it in here, fill that in. Second to the last one is 0.913, and that will go up to this spot. And the last one is 100%, which goes to the very end. Okay, and so remember this, like this little item down here, this 33 to 36, this is really 33 and up to 36, but does not include 36. And since I didn't have any athletes who were 36, there is no value in this column to the right of this 36, okay? So I know that everybody was at least 35 in some many days, but no one actually hit the 36Y, which means there's nothing to the right of that, okay? And that is it. If you do your relative frequency graph, your last bar should always be 1.0, okay? So this should always add up to be 1.0. If you didn't have stuff like this already written out for you, or you didn't actually script that, I would probably write these numbers in. You know, I would probably say, you know what, this guy here is 0.0435, okay, and put them all in, 0.2609. If they, again, they weren't already located to the left, all right? If you just had them in your calculator and you were asked to graph it, I would probably put them in if they weren't already scripted somewhere else, all right? Because it's hard to look at that and say, wow, that's 0.0435. That wouldn't make sense. Cool. All right, let's move on to something different. And I'm going to talk about Arizona State University football, which is my alma mater. And this is the number of points that were scored during the 2016 season, okay? Now, if you look at those, they ask you for a couple things. They say find the mean, the standard deviation, and the interquartile range. And that's not new to us. You have practiced this already many times. And if you were to do this quickly on your calculator, I would put all of these in my L1. All right. And then I would do a stat, calc. Okay. And then the first item, of course, is one bar stats. All right. Now, normally what I'd do, I'd have you take a minute and do that. In fact, it would be wise to do that right now. Maybe hit pause on this. Make sure that you're able to use your calculator correctly, because just because I can do it and show you how it makes sense doesn't mean that it's always easy for students to do as well. So hit pause, give this a try, put this in your graphing calculator in L1, okay? Remember, if you need to clear a list, okay, I'm gonna put this down here. If you need to clear a list, okay, make sure you hit the clear button. Okay, clear is right here. I'm gonna highlight it on your calculator, okay, and then hit enter. Okay, clear, enter. All right, so do me a favor, hit pause, put those in your graphing calculator, and do a stat calc, one of our stats, and we'll see if you get the same thing that I am showing on my screen, okay? All right, so hit pause and give that a try. Okay, so notice what I have here. I have a couple things. First thing is I have an X bar, that is my mean. I don't have to write out the word mean. I can just say, hey, this is 33 and 1/3, and that is the average number of points this team scored during the 2016 season, okay? All right, now, it asks for the standard deviation, and the standard deviation looks like it is 15.1. Okay, now what that means is this team didn't score 33.3 points every single game, but on average, their point totals were about 15 points away from what this true average was. Okay, I'll repeat that again. On average, the team scored about 15 points away from this true average of 33.3. Okay, last thing is a median and an interquartile range. Now, keeping the screen right here, if you scroll down, okay, you'll get the second screen, all right? And you'll have a couple of things that are important. First, you'll have a median. Okay, your median is 32. And remember, your interquartile range is Q3 minus Q1. Okay, so my Q3 is 39.5. Too many decimals. Okay, and my Q1 is 21.5. All right, and again, the way you find that is once you did this one of our stats, just scroll down and you'll get this new screen. Okay. All right, if you subtract those, you will get, I believe, 18. All right, so write those numbers down. Keep them handy because we're going to look at those in context to something else that we're going to use in terms of evaluation. All right. All right, so here's what it says. This team is hoping to improve their total points by 10 points per game for the upcoming season. Okay, find the expected point totals for each of these 12 games. All right, so here are the old totals, and what I want to do is, what would the new totals be if I increase by 10 points per game? All right, so this would be 45, this would be 28, this would be 36, 45, 42, 26, 33, 30, 61, 42, 72. People want to know if that's real. That is true. You just scored that many in a game. And 54. Okay. Now, if you don't want to do this in your head, okay, or if you don't want students, if you as a student don't want to do it in your head, because maybe sometimes they'll give you something a little bit more ugly than add 10. Okay. Maybe they'll say add 16.4, and you're like, I don't want to add 16.4 in my head. You can do this. If all your items are in L1 from the beginning, if this original data is in L1, here's what you can do. You must highlight your L2, okay, highlight it, okay, hit enter, and then in the little bar underneath, hit L1 plus 10. Remember, L1 is the same as the second button, and then just the number 1. okay, and that'll get that there. And then once you hit enter, you'll get all these items here, which is what we have in that spot. And I just found a mistake, 78. Thank you. Okay, so sometimes it's better to do it this way so that you don't make a silly mistake like I did there originally. Okay, even adding 10 can have its struggles. Okay, now here's the new question. It says find the new mean, the new standard deviation, the new median, and the new interquartile range of these new scores. Okay, and so we will do that command. Take a moment, hit pause, and we'll see what you get. Okay, so when you do this, okay, and remember this is the same command, you're going to go to stat, okay, you'll scroll over to calc, and it's one variable statistics. That's what I think it is. One of our stats, and make sure you put in L2, all right, because that's where your new data is, and you're going to get a bunch of new items, all right. You'll notice that your X bar is a little different from before. It's actually 43.3. Okay. Your S of X, if you did that correctly, is still 15.1. Okay. Your median, okay, changed a little bit, okay, is 42. And your interquartile range, we'll have to do that calculation real quick, which is Q3 minus Q1, it's 49.5 minus 31.5. Okay, so your Q3 and your Q1 changed, okay? And if you do that subtraction, that gives you 18. All right, so question is, which one's changed from the previous data, okay? If you look at our new work, okay, our old data had, I think, 33.3. Okay, so I know that by adding data values, adding a number to all your data values, okay, does change, okay, your mean. Okay, in fact, if I'm jumping from 33.3 to 43.3, both with hats on it, yeah, you notice they jump by 10, and that would make sense because you increase each data value by 10. Okay, did it change the standard deviation? Well, the last one was 15.1, and this is also 15.1. So no, the standard deviation did not change. Okay, why did it not change? Well, the biggest reason is this. The spacing that you have between your original numbers, okay, is no different than the spacing that you have from the new numbers, okay? These data values are equally spaced, okay, to their new mean as the originals were to their old mean, okay? All you did was take everything and shift it up 10, which means the mean also shifted up 10, okay? But the spacing between the values, okay, remain the same. The spacing, the variation stays the same, okay? All right, median. Did the median change? Yeah, it was 32 before, and now it's 42. So yeah, that increased by 10. So the median changed. Okay. Did the interquartile range change? Well, your Q3 changed, and your Q1 changed. Okay, but your interquartile range was 18 before, and so no, your interquartile range does not change. Okay, only the mean and the median. Okay, and that's always true when we add a value, okay, to all of your data. Okay, now is the same thing holds true when you multiply. Okay, so same question. Notice I have my original data. This is not the data where you added 10. Okay, this is not the data from the previous screen. This is the original data. And here's what I want to do. Instead of adding 10 to each of these, what I want to do to improve my offensive game is to double my score. Okay, so meaning I don't want 35 points a game. I want, instead of 35 points that first game, I want 70. Okay, instead of 18, I want 36. Okay, and so on. Now I'm going to do it this way because I think it's easy to multiply by 2. Should be easier than adding by 10. But nevertheless, I'm going to check my work. I don't know if it's possible to score 102 points in a game or 136, but that's just how the problem's written. Okay. Now, if you're like me and you want to check it afterwards, okay, here's what you're going to do. You're going to go to your L3. Okay. Notice I left my L2 in there. I'm not going to use that anymore, but that's okay. I don't have to delete it. Okay. And all I'm going to do from my L3 is I'm going to highlight it. Okay. Highlight your L3 and then make L1 times 2. All right. And when you do that and hit enter, you should get all these items. I'm going to check my work to make sure I didn't do anything wrong, because we all make silly mistakes from time to time. And it only goes down so many, but this last one should be 88. That's right. Okay. And then here's what I'd like you to do. Take a moment and do a 1var stats with this. Okay, so let's do stat. And we'll go to calc. And it's 1var stat. L3 now. Okay, and I'm going to have a brand new mean. Okay, I'm going to have a new standard deviation. I'm going to have a new median and a new interquartile range. All right, take a moment, put all these in your L3, and then do this command off to the left, if you don't mind. Okay, and we'll see what you get. Okay, and what I'll do is I'll pause this for a second. You can pause it, and we'll see if we get the same thing. Okay. Okay, so let me see what I got. Hopefully you have something similar. My new average, okay, if you were to do this, is 66.6 with a hat on it. In fact, I'll write a bunch of these out so it looks better. Oh, sorry. All right, there we go. My standard deviation is 30.21. Okay, you should know something unique about that. We'll talk about that in a second. Your median is 64. And your interquartile range, well, this is 79, which is your Q3, minus your Q1, which is 43. And that finishes with 36. Okay, now, if you consider what your original data was for this group, okay, remember your original X bar was 33 1/3. Okay, so by multiplying by 2, okay, did it change your mean? It did change your mean. Okay, in fact, you notice that it is double. Okay, multiplied by 2. Hey, what about our standard deviation? It didn't change last time when I added. Does it change now? It does. Remember it was 15.1 before? Okay, and now it is 30.21. So this also doubled. Okay, so it did affect our standard deviation. Okay. Our median before was 32 for the original data. Okay, so our median for this was 32. Now it's 64. I don't know why it's doing that. Okay, this is also a double. So it does affect your median. Okay, and your interquartile range. It did give me a new Q3, a new Q1, and the difference is 36. Okay, before it was 18. That is also double. Okay, so it changed everything. Okay, now what's cool is, what did it change everything by? Well, it changed everything by a multiple of 2. Okay, and why? It's because, well, you doubled all your original data. Okay, so change by a multiple of 2. All right, so a couple of rules here. I'm just going to write this at the top here. Again, remember, if you add or subtract any number to all your data values, okay, then what that means is that's what I meant, add or subtract any number, then what's going to happen is it'll affect your mean, okay, and it'll affect your median, okay. But if you multiply, or in fact divide, okay, any number, then what's going to happen is it's going to change all of it, okay. It'll change both your mean, your median, okay, and then it'll also change your interquartile range and your standard deviation. Okay, so highly effective when you multiply all your data values by something. If you add or subtract something to it,